the case of a rod which is lying on a horizontal frictionless surface. So we are looking from the top. This is a rod which has got a mass 2 kg and length is L. From here to here length is L. So now this end is given a velocity 2v and this end is given a velocity v. We are asked, that is, what is the velocity of center of mass at this instance. So thing to note over here is, when we are looking from the top and this is lying on a frictionless surface in a horizontal plane, then this is not going to the instantaneous acceleration. How do we find the instantaneous acceleration is, that is, we know acceleration lying over here. What we do is, we connect these two, suppose over here. The acceleration will be somewhere over here. So about this, the omega for the whole rod is going to be same. So if this is instantaneous acceleration, let's say this point P, whereas C is center of mass, that is, if this is total length is L, so from here to here is L by 2. That is, AC is L by 2 and CB is also L by 2, but PB is not L by 2. This is the instantaneous acceleration about which the whole rod is rotating in the horizontal circle on the table. So if this is instantaneous acceleration, let's say we take this length from here to here as x. So from here to here it becomes L minus x. So now whole body is rotating about this axis with angular velocity omega. So we know V is equal to r omega, where V stands for the velocity of the point which is situated at a distance r from the axis of rotation when the body is rotating with angular velocity omega. So for this, if we talk about, that is, omega is equal to V by r. So omega for the whole rod is same. If we take 2V, so it means 2V by x, 2V by x should be equal to V by, this is moving in the circle of radius this much, that is L minus x. We get cancelled, so it becomes 2 into L minus x is equal to x. So 2L minus 2x is equal to x. So 2L is equal to 3x, x is equal to 2L by 3. So instantaneous axis of rotation is at a distance of 2L by 3 from the end A. Now the whole body is rotating about this axis with some angular velocity. Now we can easily find what is the angular velocity of the whole body about this axis. So omega is equal to V by r. V is V, r is how much? This is L minus x. L minus x is what? 2L by 3 is equal to V upon 3L minus 2L. L by 3 is equal to 3V by L. This is, we get omega is equal to 3V by L. So this is angular velocity in terms of V and L. We are interested in finding the velocity of center of mass. So now this is axis of rotation, this axis of rotation, and this center of mass will be moving with a velocity, that is VCM, perpendicular to this line joining this and this, P and C. This center of mass shall be moving in this circle of radius this with P as the center. So now from here to here, what is the distance? From here to here, this distance is this distance minus this distance. So CP, we are interested in finding CP. What is this distance? Is equal to 2L by 3. From here to here, 2L by 3 minus AC. What is AC? This is C is center of mass of the whole rod. So this is L by 2 minus L by 2. So this comes out to be 4, we can cross multiply. It is 4L minus 3L upon 6 is equal to L by 6. So this distance is L by 6. Now we wish to find what is VCM. VCM is equal to obviously r omega. VCM is equal to r omega. So VCM, that is velocity of center of mass, is r. R from here we have got it as L by 6. And omega, what is omega of the whole rod? Omega of the whole rod we have calculated over here, that is 3V by L. 3V by L. So that comes out to be, that is V by 2 is velocity of center of mass. So velocity of center of mass is V by 2. Over here the point to be noted is, when this velocity is V, this is 2V, it is not necessary that is center of mass, that will be also the axis of rotation also. Here the axis of rotation is here, about which even the center of mass is also revolving, but the angular velocity for the whole body is going to be same. So in this question what we have done is, when the velocities of these two ends they are given, that is, first we find where is the axis of rotation. Once that axis of rotation is found, then from there we have found what is the distance of center of mass from this axis of rotation, that is we have found r. Then we have once again used V is equal to r omega to find the velocity of center of mass.